Okay, welcome back to Math 60 here. Let's see, you've done a lot already. You should have a pretty good idea of how the course works. The goal here is to develop a good foundation in algebra and good algebra skills. Focus on the vocabulary. That's really important in this class. And also be sure to ask lots of questions. And if you do those things, you'll do fine. You'll do fine. Also, don't fall behind. The stuff we do at the beginning might seem kind of easy to you, and the tendency would be to not take it seriously enough. But my advice is take that as an opportunity to really get ahead of the game, ask a lot of questions, and whatever you do, don't fall behind. All right. Well, in this problem set, you're going to learn about the integers. But before we do that, let's do a little bit of review. In last problem set, you did problems like this. Let's see, what would you call this? Would you call this a sentence or an expression? All right, this would be an expression because it doesn't have an equal sign. And remember what terms are? Remember what terms are in algebra? Terms are numbers that are being added together. So if you read it back, it says 4 times 5, and this says plus 2 times 3 times 4, and this says plus 12. So terms are separated by a plus sign, so this whole thing is one term. 4 times 5 is actually one term. And then this whole thing is one term, because these numbers here are being multiplied. They're not being added, are they? 2 times 3 times 4. And the 12 is a term. So this expression has 3 terms. In terms of simplifying it, though, we'd follow the order of operations and do the multiplications first. 4 times 5 is 20. 2 times 3 is 6. Times 4 is 24. Plus 12. I get 44 plus 12 when you do this addition. Final answer is 56. This one's a little trickier. If it says circle the terms, remember terms are being added. They're numbers being added. So if you read it back, it says 4 plus 3 times this quantity here. See? So the 4 is a term that's being added, and the other thing that's being added is this whole quantity. 3 times this blob is a term. Just this 4 times 5 was a term. This is all one term because this is a multiplication right here. Anyway, so there's 2 terms. And let's see, what would you do first? You would work inside the parentheses. That's what the order of operations says, right? You write the 5 times 7 is 35. Now notice, write the whole problem down. This is something, unless you've been doing algebra or math recently, you might not do this, but in algebra class, you always want to write the whole problem down in each step. And then you look inside the parentheses, you would add the 2 plus the 35 and get 37. Now read it back. 4 plus 3 times 37, you do the multiplication. That gives you 111, and then finally you add. It looks easy, but unless you get in there and do this yourself, it can be kind of tricky, especially on quizzes and tests. Let's see. So we're going to introduce the integers here. First of all, recall the whole numbers. Start with 0, 0, 1, 2, 3, and 4, and so on. The integers can be thought of as the whole numbers together with all their opposites. We say -1 is the opposite of 1. -2 is the opposite of 2, and so on. And the way to think about it on the number line, think of it like this. The whole numbers start with 0 and go to the right. This is called the positive direction. The negative whole numbers would go to the left. So in other words, -2 is the opposite of 2. It's on the other side of 0. Let's see, what would be the opposite of -4? The opposite of -4 would be 4. And what would be the opposite of 0? Think about that. What is the opposite of 0? Anyway, in this problem set, the focus is going to be on adding integers. This is something that you've definitely seen before if you've taken much math at all. We're going to go through this rather quickly, so if you feel rusty on this, make sure you work hard on this stuff, because we're going to use this the whole quarter. When you add two positive integers together, it's always positive. You can think about it in terms of money, right? If you win $5 and then you win $9, you've won 14. Another way to think of it is on the number line. That's kind of helpful. Even if you don't draw this is a nice way to think of it in your head. You start at the number 5 and you're adding 9, which means you're moving 9 in the positive direction. Remember, the right is the positive direction. So if you're at 5 and you move 9 to the right, where do you end up? You end up at 14. Think of it as driving along a highway. If you're 5 miles north of Seattle and you drive 9 miles, you're 14 miles north of Seattle. See? Okay, so there's lots of ways of thinking about this. It's important that you have a way of thinking of it, though. When you add two negatives together, it's going to be negative, isn't it? You can think about it in terms of money. If you lose $5 and then you lose 9, you've lost a total of 14. Or the number line works here too. Look, if you start at the first number, -5, and since you're adding -9, that means you're moving to the left. Remember, to the left is the negative direction. So if you start at -5 and you move 9 to the left, to the negative direction, don't you become more negative? You end up at -14. So that's a nice graphical way to understand it. This is where it gets tricky, right? When you have a negative plus a positive, it depends on which is bigger, doesn't it? In terms of money, if you lose 5 and then win 9, you're up 4, so positive 4. But how would that work on the number line? You start the first number, -5, and you move 9 to the right. So if you're 5 miles south of Seattle and you drive 9 miles north, you actually drive through Seattle, and now you're 4 miles north, right? You're in the positive direction 4. So when you add a negative and a positive, it depends on which is bigger. Here's another way to do it, by the way. This is a nice, fast way to think of it. Forget about the negative sign for now. When they have different signs, just take the bigger minus the smaller. 9 minus 5 is 4. Give your answer the sign of whichever is the bigger number. So since the bigger number is positive, it's positive 4. You see what I'm saying? For this one, you could say, since you're adding integers with different signs, take the bigger minus the smaller. Just forget about the sign for now. 17 minus 12 is 5, right? But since the bigger one is negative, it would be -5. That's a nice way to think of it. In terms of money, if you win $12 and lose 17, you're down 5. In terms of the number line, if you start at 12, you start at positive 12 here, see? And then you move 17 to the left, you've actually crossed 0, and now you end up 5 to the left of 0. That's a nice way of thinking of it. How about this one? Is this going to be positive or negative? -8 plus 9, you could take the bigger minus the smaller. 19 minus 8 is 11, and since the bigger one's positive, it's positive 11. Or number line, start at -8, move 19 to the right, you end up at positive 11, right? When you add two negatives here, this answer is going to be negative. It's going to be -32. If you lose $14, you lose 18, you've lost a total of 32. Or number line, you start at the first number, -14, and you go 18 to the left, you end up at -32 on the number line. How about this? What is -8 plus 8? That's 0, and you can think in terms of money. If you lose $8, then win $8, you're at back to 0. You're broke even. Or with the number line idea, if you start at -8 and move 8 to the right, it puts you right on top of 0, doesn't it? How about 0 plus 6? If you don't win anything, then you win 6. You have a total of $6. Or you start at 0, move 6 to the right, you end up at 6. So there's different ways of looking at addition. And frankly, the more ways you can think of it, the better. The deeper your understanding, which is what you're trying to do here. If you were to add these three integers together, if you add the first two together, -3 plus 5 is 2, plus -9 is -7. So what you might be wondering is, why didn't you just add the -3 to the -9 first, and then the 5? Can you add them in a different order? And the answer is yes. With addition, it works that way. It's called the commutative law of addition. It says that when you add numbers, you can move them around in any order. It works for addition. It doesn't work for all the operations. It works for addition, though. So it might be easier to do it that way, even though technically you're violating the order of operations. In some cases, it's okay to do. So if you added the -3 plus the -9, you get -12. Then you add 5 to that, you end up with the same place, right? You still get -7. That's what we got before, see? -7. All right, so this one, let's see. If you were to add the two negatives here, you don't have to do it this way, but I think it's a little easier. Maybe you agree. -5 plus -8 is -13. And then the 4 plus the 13 is 17. Your final answer is going to be positive, isn't it? Because the 17 is bigger than 13, you get 4. Okay, let's see here. I have a couple for you to try. Why don't you try these? Go ahead, hit the pause button, and we'll go over these in just a minute. Okay, ready? First one is going to be negative, right? You could take 13 minus 5 and get 8, but your answer is -8 because the 13's the bigger one's negative, right? You add two negatives together, it's going to be negative. It's going to be -17. This one, did you use the commutative law? Did you add the -5 plus the -3 get -8? And then you add the 4 and the 12 and get 16. Your answer should be 8. And the last one, did you use the commutative law? Add 23 and 8 and get 31. Negative 14, negative 3, you get negative 17. You those together, you get 14. Okay, I guess we're done here. We'll see you later. Bye-bye.